Let's look at the next sorting algorithm. It's called bubble sort. And it's probably the most commonly taught first sorting algorithms when you start with the sort as a topic. It's a very simple algorithm. What it does is every time you start sorting the elements, you make sure that the one element bubbles down to its correct position. Right? And this is probably the most time-consuming sorting algorithm, one of the most time-consuming algorithms, but pretty easy to understand. So let's see how it works. Fine. So we consider this array which we want to sort. So a bubble sort starts with comparing the first two elements, and whichever element is, let us say I want to sort in ascending order. Fine. So that means the biggest number should go towards the right. So between these two numbers, 10 is bigger, so it will move 10 towards the right, 2 towards the left. So we'll swap these two. Fine. Next, we'll consider the next two index numbers, index 1 and index 2, 10 and 42. 42 is already bigger and it's towards the right, so nothing to change. Next, consider the next two index numbers, index 2 and index 3. In this, 42 is bigger, 22 is smaller, so 42 has to move towards the right. So we'll swap these two. So 42 goes here, 22 comes here. So we did a swap operation here. Next, consider the next two index numbers, 42 and 60. Between these two, 60 is bigger. So 60 is already on the right hand side, so nothing to do. Next, consider the last two index numbers, 60 and 30. 30 is smaller, 60 is bigger. 60 has to move towards the next position. So to swap these two, 60 comes here, 30 goes here. So at and that's all. No more elements have to be there to be considered. So we went through the whole array once, and we saw that 60, which is the largest element, comes to the rightmost position, which is the correct position for the ascending order sorting. These are not sorted yet. Only 60 has been sorted. So what we do is we restart from here again. We take this array. Now consider this as the starting position, right? And do the whole set of operations that we did just now of swapping and comparing all over again, starting from the beginning again. So again, take these two and see if they are to be swapped. 2 and 10 are already in the correct position, nothing to be done, right? So the array remains as it is, right? So compare 10 and 22. Between 10 and 22, they're already in proper position, nothing to be done. Leave it as it is. Okay. Between 22 and 42 also, nothing to be done. It's in proper order. So we'll not do anything. Okay. Now between 42 and 30, obviously it's not in the proper order because 42 is bigger and 30 is smaller. So we have to swap these two. So we'll swap the two values and put them in the correct position. 30 comes here, 42 goes here, right? So that's and then consider the last two. The last two elements need not be considered because 60 is already its correct position. So there is no need to consider these two for a comparison, but just for because at the initial stage you might not want to add this complexity of ignoring 60. So let's say we'll consider 42 and 60 also. They're already in sorted order, nothing to be done. So we'll leave the array as it is, and this becomes my output at the end of second pass. Output meaning the position status of the array at the end of second pass. So you can see 42 and 60 have reached their correct position, right? Okay, in this array, f- not a very great example. These also have reached the correct position, but ideally that would not happen in other arrays. So where you need to go through the whole set again for second time, third time, fourth time. So depending on if there are five, six elements, we have done one, two, three, four, five comparisons, right, in one pass. Like that, you have to repeat in the worst case scenario that is not the optimized code, five times we'll have to repeat the comparison. So five comparisons in each pass, the passes would be repeat repeated 5 times. Fine. So that is how the bubble sort works. So with respect to writing the code for this, it's pretty straightforward. You just put two loops. So I start with for I range of uh, item list 0 because the 6 elements 5 comparisons. So we take length of item list minus 1, item list being the list that we want to sort. Start another inner loop j range of item list minus 1. So we are not optimizing it as of now, is doing the worst case kind of comparison where we are doing the maximum comparisons possible. This can be optimized to reduce the comparisons, but that's for a later stage. Fine. So at each time we come in, we compare two elements, consecutive elements. If the one element, the element is greater than the next index value, then we do swap those elements, else nothing to be done, leave it as it is. So this inner for loop gives us the first, the inner set of comparison, that is the set of comparison that we did here. Okay, this set of comparisons that is done in the inner for loop. The repetition of this for n minus 1 times is taken care by the outer for loop, right? So that's the very basis of what bubble sort does. I'm sure you must have seen this algorithm a number of times before, so we'll not uh, go into too much of details in this. Hope the working is clear, right?